This video is to review correlation, line of best fit, and qualitative graphs. It is being used to go over our study guide and make sure that we understand what is done in each problem. In our first problem, we are creating a scatter plot based on the life expectancy of people. We're comparing the years, which will be our x value, and the life expectancy, which will be our y value. In part A, we're asked to construct a scatter plot and draw the line of best fit that represents the data. In this scatter plot, I chose to increase the years based on tens and the life expectancy based on tens. I chose tens because on your graphs you are given 12 lines, and the best way to represent this data would be to count by tens. As you can see, the red is the scatter plot data, the black is the line of best fit, and the green is the oval that I drew to help represent the data to help ensure that I drew the best line of best fit. In part B, we are asked to use the line of best fit to make a conjecture, which just means to make a prediction about the life expectancy for a person born in 2020. We have to pay attention to the fact that our x values are years since 1900. So when we're dealing with 100 years, we're talking about the year 2000. So if we're making a conjecture about someone born in the year 2020, we are talking about 120 years. Because this line of best fit will go all the way out to 120 years, there's no need to find the equation for the line of best fit. We can simply find out that at 120 years, a person is expected to live to be about 87, somewhere in that 85 to 90 range. In our next question, we've been asked to create a scatter plot with wind speed and temperature. If you notice, in this table, we have wind speed and temperature 2 times. This is just one table. The second wind speed picks up underneath the first. So the scatter plot data is shown in this graph in purple. I found that it was best to count the wind speed by 5s and the temperature by 2s. For part A, we have completed the task. We constructed a scatter plot and then drew the best line of best fit. In part B, we're asked to write an equation for the line of best fit. And in order to create the equation for the line of best fit, we have to know 2 pieces of information. We have to know a slope and we have to know a y-intercept. So in order to create the slope, we need to know 2 points that are on our line of best fit. So there appears to be a point here and a point here. When finding the slope, remember we use the rise over the run, but we do have to pay attention to what our scale is. And because on the y-axis we're counting by 2s, when we come down 2 spaces, that is really -4. And when we move to the right, that is really +15, because we are counting by 5s on that x-axis. So our slope here appears to be -4/15. And our y-intercept is where we cross the y-axis, and in this case we are crossing the y-axis at about 24. So our equation would be y equals -4/15 x plus 24. Now we can use this equation to make a conjecture about the wind chill with 60-mile-per-hour winds. We want to find out what the temperature would be. So 60 is going to be our x value. we'll say y equals negative 4/15 times 60 plus 24. So we filled 60 in for our x value, and when we multiply negative 4/15 times 60, we come up with negative 16, and add 24 to get y equals 8. So we're saying when there's a wind chill of 60 miles per hour, our temperature would be 8 degrees. So we can check that using our line of best fit, since we do go to 60 miles per hour on our graph. And that does appear to meet around 6, 7, or 8 degrees. So our answer is reasonable. For our next problem, we're given a scatter plot and we're asked to write the equation in slope-intercept form. Again, we have to know two pieces of information. We have to find the slope and we have to find the y-intercept. So starting with the slope, we have to identify 2 points that are on our line. There appears to be a point here and a point here. When using the rise over the run, we have to make sure that we take into account what the scale is. So our rise here is -4. Our run, we're running 3 spaces, but we have kind of a unique labeling of our x-axis here. We've taken 3 spaces to get to 100. So if you say 100 divided by 3, that means that each line is worth 33.3 or 33 1/3. So if we have 3 spaces, we have 33 1/3, 33 1/3, and 33 1/3, which will equal that 100. So our slope is -4 over 100, which will reduce to be -1 over 25. If you identify your y-intercept, you're just extending your line to see where it crosses the y-axis, and here it appears to cross at 15 or 16. When using the equation, you're going to find that it's actually closer to 15, but either would work. So our equation is going to be y equals -1 over 25x plus 15. The second part of our question asks us to make a conjecture or prediction about the amount of gas remaining after 225 miles. So if we're going to use our equation for that, we'll plug in 225 for our x value, since our miles is our x-axis. So -1/25 times 225 is -9. And -9 plus 15 is 6. Again, we can check this using our graph because our graph does cover 225 miles. So at about 225 miles, we have about 6 gallons remaining. This is a reasonable answer. In our next question, we're asked to compare the height and shoe size of women. And to set up our scale, we can count by ones on our x-axis because we have 12 lines and we only need to go to size 9.5. For the height, notice all of the numbers are relatively around the same and they're all kind of higher up on where our graph would be, so we can use this broken axis. Normally that's going to lead to a misleading graph, but here it's a way to zoom in on the data and really see the trend. So again, we can use that oval around the data to kind of help decide where to put our line of best fit. And here, our line of best fit appears to go in this area. The next portion of our question asks us to make a conjecture about a female who wears a size 5 shoe. So we will find out where that meets on our line of best fit, and according to the line that we've drawn here, it appears that a woman with a size 5 shoe would be around 58 inches. So anywhere in that 57 to 60 inch range would be a reasonable conjecture about a woman who wears a size 5 shoe. In our next question, we're just simply making sure that we can identify the equation for a line of best fit if it's given to us. And because it's multiple choice, we can use our test-taking skills. We can automatically eliminate two answers by noticing that we have positive correlation, which means that our slope has to be positive. So we can automatically eliminate B because it has a negative slope and D because it has a negative slope. That leaves us left with A and C. So now, because they both have the same y-intercept of positive 34, we need to identify whether we have a 1/3 slope or a 3/1 slope. We do that by making sure that we can identify 2 points that are actually on our line. Whether they are part of our scatter plot data or not, we have to make sure that those points are on the line. It appears that we have a point located here and here, and that would be a 1/3 slope. So our answer is A.